Hi, welcome back to another Algebra 1 lesson. This is part 2 of looking at the intercepts and the graph. So what we're looking at today is roots and zeros. We've been actually solving for roots all along. The root is just a value that makes an equation true. We call it the solution. So when we looked at problems like this one here in the previous lesson, this 3x equals 6, when we are solving that, what we are actually doing is finding the root. So if I divide both sides by 3, right, we're doing the inverse operation of multiplication. So we divide both sides by 3 and we get x equals 2. That is our root. So today I'm going to teach you a little bit different way to go about solving this. And this is just going to help set you up for the next chapter that we're going to be doing, where we're putting things in slope-intercept form and graphing them. So this is a great way to set you up for that by just introducing you into a second way of how to solve an equation. So we're going to find the roots and we're going to find the zeros by then looking at the graph. And the zero is where it crosses the x-axis, which also happens to be the root or the solution to the equation. So let's jump into this. This is my second time recording this. I accidentally hit the wrong button the last time and stopped it instead of kept recording. So take 2, here we go. We're going to solve negative 2x plus 7 equals 1 by graphing. So in order to do that, what we have to do is get it set equal to 0. And I do that by saying, okay, I've got negative 2x plus 7 equals 1. Either side could be set equal to 0, but to me it looks a whole lot easier to get this set equal to 0 because all I have to do is subtract 1 from both sides, right? It's going to take more work to get this side over here equal to 0. So 1 take away 1 we know is 0. 7 take away 1 we know is 6. And then we have negative 2x. So what we do then to be able to graph this, once we have it set equal to 0, we can get rid of that 0 and replace it with a y or f of x. So f of x is equal to negative 2x plus 6. Now this is written in slope-intercept form. Slope-intercept form. This tells me what the slope of my line is. This tells me what my y-intercept is. Now think about that. My y-intercept, we just learned in the previous video, is where the line crosses the y-axis. So we come over here and we put that point on the y-axis at positive 6, and then it tells me my slope is negative 2, which is the same as negative 2 over 1. If you remember from a previous math class, slope is rise over run. So negative 2 means I'm going to drop down 2. I go over 1. Down 2, over 1. Down 2, over 1. And there it is. There is the solution, the root. The 0 happens here at 1, 2, 3, when x is 3. So we know that x is equal to 3. And another way that we could do this, we could have looked at it algebraically. We could have said, okay, let's see, I know to get x by itself, I need to subtract 7 from both sides. So plus 7, then we take away 7 to get it to be 0. Property of equality says if I take away 0 on this side, I've got to come over here and do it over here. So that's gone. So now I have negative 2x equals a negative 6. Divide both sides by negative 2. That's the inverse of multiplication is division. Divide both sides and I get x equals a negative divided by a negative makes it a positive. So it's a positive 3. I still get the same answer no matter which way I do it. So we can do it algebraically. We can do it graphically. The other thing that we could have done is, if I'm going to scroll on down here, and instead of me writing it all out, I'm going to show you where they did it on here. We could have moved this 2x over to the other side and the 7 and made this side be 0. We would have had a different equation. We would have had 0 equals a positive slope, a positive 2x, and a negative y-intercept at negative 6. So we would start down here at negative 6 and come up 2 over 1, up 2 over 1, up 2 over 1 until we get here. And again, we still have the answer being the same. The answer is 3. So it doesn't matter which way we do it, we still get the same answer. Isn't that nice that you can do a problem 10 different ways? Maybe not 10, but you can do it multiple different ways and get the same answer. So maybe one way makes more sense to you and another way makes more sense to another student, and boom, you can get the same answer but work it out two totally different ways using what made more sense to you. Okay, so now we're going to look at solving a nonlinear equation. I know that it's nonlinear because it has this squared in there. As soon as I look at the equation, I should know this is nonlinear. Okay, so what we're going to do again is try to get it set equal to 0. So we add the 3 to both sides. Negative 3 plus 3 is 0. Didn't just disappear, wasn't magical. It was very mathematical. Add 3, I get 0. Now I change that 0 with f of x. Now I would not at this point suggest that you try to graph this because you probably don't know how. I've not taught you how to graph a parabola. What I would suggest that you do is go to Desmos and I would type it in. So let's just do that. Desmos.com. Now, if you wanted, you could create a table, and that you are familiar with doing. But I'm going to put y equals x, and I'm holding down the shift button and hitting the number 6 to get this little 2. And then it was minus 4x plus 3. So minus 4x plus 3. And look, it graphed it for me. We can see our y-intercept is here at 3, and we can quickly find our roots, 1 and 3, where it crosses the x-axis. It crosses at 1, it crosses at 3. So if I go back over here, and I plug those values in to my equation, it should work. 1 squared is 1. 1 take away 4 is negative 3. If I plug in that other, which was 3, 3 squared is 9. 4 times 3 is 12. So 9 take away 12 is negative 3. So it works. Those are the roots. Those are the solutions. Okay. Example 7. Think about this problem right here. When we solved this algebraically and we said, okay, 8 equals 0, we know that is not true. There is not a solution for that. 8 cannot equal 0. But with what we're doing now, it tells me, okay, well, if you get it set equal to 0, change that 0 with a y. So now or an f of x. So now I have that 8 equals y. So that doesn't matter. It doesn't matter if x is 1, if y is 1, or if x is 2, x is 3, x is 4, x is negative 10. It does not matter what the value of x is. Y is still up here at 8. Still up here at 8. 1, 2, 3, 4, 5, 6, 7, 8. Here it is. This is y equals 8. It's a horizontal line. Now, if you think about a horizontal line, the slope of a horizontal line is 0. There is no slope. There's no steepness. So back to this problem, what we're looking for is where is it going to cross the x-axis? Well, if its slope is 0, there's no steepness. It's just a flat line. We know it's never, ever going to go down here to cross the x-axis. So there is no solution. So if we think about it graphically, y equals 8 is a horizontal line, never going to cross the x-axis, no solution. We think about it algebraically, 8 equals 0. 8 does not equal 0, so we know it is no solution. All right, and the last example that I want to go over with you is a real-world example. It says, Haley is ordering invitations for her graduation party. She only has $40 to spend. Obviously, if she only has $40 to spend, she can't spend more than that amount of money. And each invitation costs 96 cents. So she came up with the function m equals 40 minus 0.96 times p to represent the amount of money m that she has left after ordering p party invitations. Find the 0 of the function. Describe what this value means in the context of this situation. So part 1 says, well, what even is the task? What are we trying to figure out here? Well, what we're trying to figure out is what is the 0 of the function, right? If I need to find the 0 of the function and describe what it means in terms of this problem. How can I determine the meaning of the 0 from the graph of the function? Well, we can review graphing linear functions and we can label our x and y axis. All right, so part 2, how will we approach the task? Well, we're going to have to graph it by making a table of values or maybe trying to put it in slope-intercept form, but I would just make a table of values at this point and figure out what our solution is. Well, before we do that, we can kind of estimate it. We know that each invitation costs less than $1. So we know that she can have more than $40 because 40 divided by 1 is 40 invitations. All right, so next we're going to graph it. I don't know what this is. This is kind of weird looking. Maybe we won't graph it. Maybe we'll just pretend to graph it. I don't know. Okay, so next what we can do then is estimate the solution. Well, let's just think about this. If I was to graph this, back here, we know that she's starting at 40, and if she was spending $1 at a time and goes down, that means that she could buy roughly 40 invitations if they were exactly $1, right? So the solution appears to be close to 40 invitations. It says that's not correct. It would definitely help if we could look at the picture of the graph. If I was to graph it, apparently it goes a little above 40, but I would have accepted 40 as a correct answer because you can't tell. It's 96 cents. If we're going down 0.96, that's very, very difficult to do graphically. You don't know how to go down 0.96, right? That's horrible. So if we round it to the nearest hundredth, the 0 of the function is about 41.67. But again, you're not going to know that because you can't tell that by looking at the graph. So let's go back. Let's just type it into Desmos and see if it gives it to us. Y equals 40 minus 0.96p. Since it won't let me graph it on there, we'll do y equals 40 minus 0.96x. And we're going to have to zoom out to be able to see it. There we go. Now we can tell. It's a little bit beyond 40. If we keep zooming in, we can see here. It's 41.667. So rather than just, since my graph on here didn't work, rather than just trying to guess, let's go to Desmos and graph it. Boom, there it is, 41.667. Well, we know that 41.667 invitations doesn't make sense. She's not going to be able to order 0.667 of an invitation. So let's think about what this does mean in terms of our problem. Our solution means that she can only order 41 invitations. 41 invitations is her limit because if she orders 42, we know that's going to be more than her $40, right? 42 times 0.96 is $40.32. She only has $40. So 42 invitations cost more than $40. And she cannot order only part of an invitation. So 41 invitations is her limit. That's how many she can order. Because if she orders 42 invitations, the cost is more than $40. The cost is more than $40, and she cannot order part of an invitation, so we can't do the 41.667. And how can we check to see if that's reasonable? Well, we knew it had to be really close to 40 because if 96 cents is almost $1, so it makes sense that if each one costs almost $1, she can order really close to 40 invitations. And then avoid a common error. The common error is to think that, well, since she can order 41.667, we're going to round it up to 42. No, that doesn't make sense. We can't round it up to 42 because then she's going to spend more money. So make sure to logically reason through these as you are doing them and think about what makes sense. And this says another common error is to think that the zero of the function is 40 because that's the y-intercept. But remember, we're not looking for spending zero, or, how do I want to put this? We're not looking for the y-intercept. We're not looking for that 40. We're looking for the x-intercept. How many invitations can she order? All right, and that takes care of this lesson. I hope that made sense. I feel like I kind of bumbled my way through that. That was my second time recording it, so it should have been even better. But anyway, there's that. I hope that it made sense. Again, if you have any questions, please be sure to reach out to me.